So hi there, my name is Devansh and welcome to OneClass YouTube channel. So in today's video, we are going to go through a couple of popular Q&A, and if you if you need any homework help or if you need one-to-one online tutoring sessions, then you can check the links in the description below. So we'll just start with the yeah. So we'll just start with the first question. Question number one. It is asking for area of sector formula. So we have to find area of sector. So sector is basically, if we have a circle, then we take a part from the center. This is radius, this is radius, this is say theta angle for the sector. So we need to find the area of this whole part. Now area for circle is pi r square. Now we are going to do the ratio and proportion thing here. So first I need to tell you that the angle for a circle, the complete angle for a circle is 360 degree. So this is for 360 degree. Now for sector, we need to find the area and we know the angle of sector is theta. And 360 I can also write it as 2 pi in radians. So I'll just write it as 2 pi. And now if we'll do just the cross multiplication or the ratio thing, the area of sector, I'll just write it as, will be equal to 2 pi over theta. I'll just take the ratio and if I cross multiply, then I will get S equals to pi r square multiplied by theta over 2 pi. Pi gets cancelled and I will get theta over 2r square. Let's just see area of sector. So S here denotes the area of sector and it is theta over 2 pi into pi r square. Okay, and then we get final answer half of r square theta. So this solution is correct for this, right? Correct solution. Great job. We'll go for question number 2. So for question number 2, how do we write 0.4 percentage as fraction? So how do we write 0.4% as fraction? Now a percentage is basically the like how like it is the part of hundredth term. So here it is written in a better way. So a percentage is defined as part of whole which is expressed as a fraction of 100. So basically this is basically 0.4% is 0.4 of 100. So I can write 0.4 of 100 as this. Now I will multiply both the sides with uh, the upper side and the numerator and the denominator with 10 to get it out from decimal, and I have 4 over 1000. Now I can divide 4 by 1000 as 4 will be 2 times of 8. I'll get 2, 20, 5 times 20, 0, this 0 and this 0 goes here. So I can write this as 4 into 250 equals to 1000. Therefore 4 over 1000 equals to 1 over 250. So this is the fraction of, or this is the fraction form of 0.4%. So here also the solution given is correct. Correct solution. Great job. Solution is correct. Now one more page. Question number 3. What is a cubic foot? Okay. Let's see the answer. So in one dimension, in order to define a cubic foot, we are going to travel from the first dimension to the third dimension. We'll start with a simple line and see how it transforms. Here's our line. So it is a one-dimensional line uh, because it only has one measurement, length. Obviously, this isn't drawn to scale, but let's say the line is 1 foot long. So for a cubic foot, I do not have the habit of calling it a foot. I generally call it as feet, feet. And so we draw, let's say this is 1 foot, and this is a simple line from A to B. And this is a 1D figure, 1D representation of 1D figure. Now we go for two-dimensional. So for two-dimensional, okay, so length, obviously let's take the line to next dimension. So for 2 dimension we get area. So if we are adding a dimension, we'll also be adding a measurement. Along with length, we now have width. So in other words, we are taking this one dimensional line and making it a two-dimensional square. Now that we are in 2 dimensions, so let me draw a square here. So again we had this AB line, then we have CD, and this is 2D figure, and again this is a square, so all the sides will have the same length, which is 1 foot. We can find the area of this square. Area of this square will be side into side, or side square, and the length of side is 1, so it will be 1 square foot. Now we'll go for 3 dimensions. So if we copy this square, so that we have 6 of them. And then use those squares to form a box. We'll have a cube. A cube is a special kind of box because all of its faces are congruent or of equal size. Since we have added another dimension to a square, we have also added another measurement height. So, yep, in the same way, here we had the length, here we had the width. So, if we are taking this square to in 3D, so we'll get a cube. It is very hard to draw a straight line, especially in this software. We have a cube. So let's just say that this is a cube and this is a 3D figure. Again, we had this A, B, C, D. Then we have few extra dimensions. So we'll write it as E, F, G, and this one is H. B, C, D. Then we have E, F, G, H. Then we have B, C, F, D. I'll just color it with red. We have this face. We have this face. We have this face. We have this face. We have the back one. We have the bottom one, and we have the top one. So we have 6 faces for a cube. Now for a cube, we calculate volume because we have one more dimension, that is height. So here it was length and here it was basically, this is the height. This should be the height. So I'll just write this as height and this is width. So the volume as it is a cube only, so all these sides will be equal to 1 foot and volume of this will be height into length into width, which is basically just side cube, not side square, side cube, and this will be 1 cubic foot. So hence we get the 1 cubic foot, which is basically the area, which is basically the volume of a 1 foot, uh, 1 foot cube, or it is basically the volume of a cube whose side length is 1 foot. Now here we have again one example finding the volume of a cube. Let's say the cube has 2 feet of length, 2 feet of length, then volume will be 2 cube, which will be 8 feet cube or 8 cubic feet. So hence we get 1 cubic foot also. So here also this is correct solution. Great job. Solution is correct. Question number, this was 3 na? 3, this was 3, 3, 3. Yep. This will be 4. So what is the value of secant of 0? We need to find secant of 0 degree. Let's just write it 0. It can also be in radians also. Yep. So let's see what is the solution given. Yeah, so secant of any angle, let's say theta, is basically inverse of cosine of that angle, or 1 over cosine of that angle, or cosine of theta is basically secant of theta. Now to find cosine of 0 degree, we take the help of unit circle. So cosine of 0 is equal to, for cosine we have we basically we do the base over hypotenuse and what are the coordinates. So yeah, so for cosine we have coordinates. For 0 degree we have coordinates. Let me just write this properly. Yep. For 0 degree we have 1 comma 0, and to find cosine we have the x, which will be x over under root of x square plus y square. Now 1, x is 1 and y is 0, so this will be 1 square plus 0 square, this will be 1. So cosine of 0 is 1. To find secant of 0, we'll just divide it with cosine of 0, 1 by 1, which is equals to 1. Hence secant of 0 is equals to 1. Secant of 0 is 1. Again, correct solution. Question number 4. This will be question number 5. Now, division property of equality. So this property states that division property of equality. Yeah, so this property states that if you divide the left hand side of an equation by a non-zero number, then you must also divide the right hand side of an equation by that number to retain the equality. Okay, so this is basically the most basic condition, or the most basic thing in maths or mathematics, that suppose if I have a equals to b, so if I'm dividing a with c, then to retain this equality condition I also have to divide b with c. So this is the basic rule of mathematics, very basic rule. In this way the equality condition is maintained between a and b, or between LHS and RHS. And we use this method to simplify the equations, or different like to manipulate the equations, or to manipulate some numbers. So here it is given the example for 100. So 100 is equals to 100. I cannot just do 100 by 4, which will be 25. 25 is not equal to 100. So to maintain the equality condition, I have to divide the RHS also with the same number. Then only I will get same value on both the sides. Here again we have one example as 2x equals to y. So I need to solve this. I need to find x in terms of y only. then what I can do, I can just divide both the sides with 2, or you can also say multiply both the sides with 1 by 2. It is just the same thing. 2x times 1 by 2 equals to y times 1 by 2. So 2 and 2 will get cancelled and x will be equal to y by 2. In the same way, I can also, let's say we have one equation 3x plus 19y equal to 24, and we need to solve this equation in terms of let's say y. So for that, what we'll do, we will um, subtract 3x from both the sides, from RHS and LHS. 19y equal to 24 minus 3x, and this will be 0. Then I can write 19y equal to 24 minus 3x. I can divide both the sides with 19 and I will get I'll get y equals to 24 minus 3x over 19. So we use this property to simplify the equations to solve the equation for a particular variable. If we have the equation for if we have a multivariate equation, then yep. So x was equal to y by 2. Correct solution. Great job. Solution is correct. This was question number 5. We'll go for question number 6. Yep. So what is 0.2 as a fraction? So I will write 0.2. Then I will just multiply this with 10 and divide this with 10, because here we have only one decimal place. So I will just multiply it and divide by 10. If I had suppose say 0.002, then I would have done 1 2 3 1 2 3 and 1 2 3 to take it out from the decimal. But we have only one decimal place, 0.2 into 10 by 10, which will be equal to 2 by 10. Now 2 by 10 I can write as 2 ones are 2, 2 fives are 10. I can write this as 1 by 5, and this now 1 and 5, like 1 ones are 1, 1 fives are 5. Again I'll get 1 5. This is the most simplified version of fraction. So expressing in the simplest form, 2 by 2, 1 by 5. So 0.2 as 1 by 5. Again, correct solution. Great job. Solution is correct. We have question number 7. Okay, so for question number 7, how to convert 45 degrees to radian. So it is saying convert. Now for this I will use the relation 360 degree. Let's see what is the solution given. So in converting from degrees to radian, we use the conversion factor based on one revolution, which is 360 degrees is equals to 2 pi. This is radian, RAD is radian. So yeah. So basically if we have a circle, then if we measure the angle, then this angle is 360 or 2 pi. 2 pi is in radians. Now we have 45 degrees to convert. So 45 degree is equals to, let's say, x radian. So we'll just take the ratio of both the things, and we'll just inverse. So I'll just write 45 over 360 equal to x over 2 5. So we'll just use the basic ratio and proportion for this. And 45 can be it can be written as 45 can be written as it will be 45 can be divided with 360. So 45, I think it will be 2 times 90, 8 times 45, 8 times it will be 360. Yep, so I can write it as 1 over 8. This will be x over 2 pi. Then I will multiply both the sides with 2 pi. So 2 pi gets cancelled. 2 will be written as 4. So this will be pi by 4 radian. X was the um, desired solution which we wanted to find. So we have converted pi by 4 radian, which is equals to 45 degree. So let's see, 45 degree is pi by 4. This is also correct solution. Great job. Now this was question number 7, I think. We'll go to question number 8. Question number 8. So the question number 8 is, what is the area of a circle using diameter 3.4 meter? So area of a circle of diameter equal to 3.4 meter. So for this, in geometry, the area enclosed by a circle of radius r is given by formula A equal to pi r square. Okay, so area of a circle is given by the formula A equal to pi r square, where r is the radius of the circle and pi is the ratio of circumference to the radius of a circle, or it is an irrational number, and pi is also a Greek letter as it is stated, and its value can be written like 1.4, 1.1, 3.14, 159 and so on. As it is an irrational number, then therefore its value never ends. Now we write radius. Now radius is basically the half of diameter, and in this case we have been given 3.4 meter as the diameter. So I can do one thing. I can write, I can find the radius, which will be, so radius will be 3.4 divided by 2, which will be, I think it will be 1.7. 3.4 divided by 2, yep, it will be 1.7. Then we use area equals to pi into 1.7 whole square, which will be, so pi into 1.7 whole square, 9.079 square units. We always write for area as square units. Okay, the unit is given as meter, so I will write this as meter square. The second method also we can do is that we can, in the formula of A equal to pi r square, we can write r as half of diameter. So area will be pi into d by 2 whole square. This will be pi by 4 d square. Now here I can just put the value of diameter. Diameter was 3.4 meter. 3.4 square, which is equal to, this should be just the same, pi divided by 4 into 3.4 whole square. Again we get the same answer with this, 9.07920 meter square. Let's see what is the answer mentioned, 9.079. Okay, so answer mentioned here is correct. Correct answer. Great job. Solution is correct. This question was question number 8. Okay. We have question number 9. We have to find indefinite integral. Find indefinite integral of secant power 4 to x dx. So what kind of method they have used? Okay, so first what I will do, I will convert this to x. So I will write u as 2x, and then I will write du. I will just differentiate that u as u equal to 2x. So du will be equal to 2 times dx. Now I will substitute u back into this equation, and du also, dx also into this equation. So I will get integral of secant power 4. This will be u, and dx will be du by 2. This will be du by 1 by 2. Now I can take 1 by 2 outside because it is a constant. Now I will write secant power 4 as secant square of u into secant square of u du. Now I will use a trigonometric property which states that 1 plus tangent square u 1 plus tangent square u equals to secant square u. So 1 by 2 integral 1 plus tangent square of u secant square of u du. Now what I will do, I will write again, I am going to do one more substitution. I will write, say, y equal to tangent of u. Then my dy will be equal to tangent of u will be secant square of u du. And now I will just divide this with secant square u, secant square u, both the sides, and I will go back to my integral and substitute the values. So my tangent of u was y, so I will write 1 plus y square, then my du is equal to dy over secant square of y. So secant square of u, then substitution for du will be dy over secant square of u. So basically with this we are just eliminating all the terms for u of u. So once we have substituted y and we have done the or we have converted the integral in terms of y, then we need to remove all the terms of u. So I will just remove them because they are equal to 1. Then I will take 1 over 2 integral dy plus 1 over 2 integral y square dy. Now I am going to use the trigonometric properties, not the trigonometric properties, calculus identities of formulas of integrals. So here 1 by 2 integral of dy will be y plus 1 by 2 integral of, sorry, not the integral, wait, I shouldn't just take this out. I will not take this out. So 1 by 2, then integration of 1 into dy will be y plus integration of y square with respect to dy will be y square power plus 1 divided by power plus 1, and as it is an indefinite integral, we'll add a constant term c. So this will be 1 by 2 y plus y cube by 3. Now we are just not going to stop at this step. We need to substitute back y in terms of u and then back in terms of x. So y was tangent of u, so 1 over 2 tangent of u plus tangent cube of u over 3 plus c. Now my u was 2x. So I will write 1 over 2 tangent of 2x plus tangent cube of 2x over 3 plus c. Let's see what is the solution given. So 1 over 2 tangent of 2x plus tangent cube of 2x over 3 plus c. Just for checking, we can differentiate this answer again and see if we get the same thing or not. So 1 by 2, if I differentiate, the tangent will be secant square and then 2 times 2x plus tangent cube 3 over 3 1, then tangent square will be okay, so tangent cube, then tangent will be secant and it will be it should be secant square, it will be secant power 4. No, we'll have the power rule. I have already written 3 here. We will have tangent square of 2x, and derivative of tangent will be secant square of 2x, then derivative of 2x will be 2, then we have plus c, so plus c will be 0. We get 2 and 2 gets cancelled from here. We get secant square 2x plus tangent square secant square 2x. Now what was the original question? Secant power 4. So tangent can be written as, from here tangent square can be written as secant square minus 1. So secant square 2x plus secant square 2x minus 1 as tangent of 2x, then minus secant square of 2x and then plus secant square of 2x. This gets cancelled, again we get the, so yeah, solution is correct. Correct solution. Great job. Now this question was question number 9. We'll go to the last question, which is question number 10. So we go to the question number 10 and we need to evaluate tangent of pi over 6. So tangent of, again we are going to take the help from this unit circle. So tangent of any angle, tangent of any angle will be given by the actual formula for unit circle, it is y by x. But for generally, if the circle is if the center coordinates of this unit circle is not at 0 comma 0, then it is basically y minus the y1, basically y minus y1 over x minus x1, where y1 and y2 x1 are center coordinates of circle. But here again we have the center coordinate as 0 comma 0, so we'll just use y by x. So tangent of pi by 3, let's write the coordinates for pi by 6. So pi by 6, the x coordinate is root 3 by 2 and y is 1 by 2. Then I will write tangent as tangent of pi by 6 as y. Y is my 1 by 2 over x. X is my root 3 by 2. I can cancel this 2 and I will get 1 by root 3, which I can also factorize and write or multiply both the sides with root 3 by root 3, and I will get root 3 by root 3 square is 3. So either my answer is this is also correct, and this is also correct. So let us see, we get tangent of pi by 6 is 1 by root 3. Root 3 by root 3 is equals to root 3 by 3. So again, correct solution. Great job. So that is all for this Q&A session, and if you like this session, then please hit this like button, and to get notified for the other live videos, you can hit the bell icon and hit the subscribe button. And if you have your own questions to submit, then you can check the links in the description below. And if you would like some homework help also, then there are the links below, just go there and check it. So that's all for this session. I'll see you in the next video. So bye.